Hey everybody, and welcome to week 4 of IT in the Forge. This week we're talking about power supplies and electricity. In case you didn't realize this before, a modern computer can't do anything without electricity. The ability to gather, process, and store data, even the data itself, is stored electrically. Now, I mentioned this before, and we'll dive more into it later, but remember, a computer doesn't even really know what a 1 or a 0 is. All it knows is on or off, meaning electricity or no electricity. Let's first talk about what a power supply is. Now, the term power supply is actually a little bit misleading because it's not actually providing or generating any power itself. A more appropriate term might be step-down transformer. In other words, it's taking the power out of your wall socket and converting it to an appropriate level and type of power that the motherboard can use to then distribute out to all the other components. To be more specific, it takes AC or alternating current and converts it to DC or direct current power. We'll talk about current a little more here in a minute, so we'll get back to those terms. But let's stick on the actual power supply unit itself for a minute. Now, one of the first things you might notice about any power supply is all the cables sticking out of it, or the lack thereof sometimes. Power supplies can come in 3 different formats. That's either modular, semi-modular, or fixed. A fixed power supply means all those power cables are actually soldered inside of the unit itself. They're there permanently. At the other end of the spectrum, we have fully modular. With fully modular power supplies, there's actually connection ports on the side of the power supply that you can connect your cables to as you need them. Semi-modular is somewhere in the middle there, where you have some power cables that are soldered and some that you can just connect to. Now, there's a lot of opinions about which of these forms is the best, but there are plus and minuses to both. Let's take a fixed power supply first. What could happen with a fixed power supply is that you end up with a bunch of cables that you don't actually need. You're definitely going to use the P1 connector, the 24 pin that powers the motherboard, and you may use a few other 12 volt or Molex connectors, but say you're not building a super complicated system. What are you going to do with all those extra cables? You know, you'd have to kind of tuck them away in the box, and it makes for not a very clean build. But the upside is, you know that those wires are actually soldered into the unit itself. They're not going anywhere. So you can pretty much count on not having any power issues with any of those cables. Now, it's pretty much the exact opposite for modular power supplies. Because you can just plug in whatever wires you need, you're not going to end up with a whole bunch of extra. But these are not soldered connections, and they're relying on a couple of plastic endpoints to make that power connection, which honestly, for the most part, usually works. But it's like the difference between taping something to a wall and nailing something to a wall. One is a lot more permanent than the other. Now, in any power supply and any power supply box, you're always going to see some big, huge number followed by a W. That's because all power supplies are rated in watts, and watts are the amount of power that it can supply to the motherboard. Everything on a motherboard has a wattage requirement to be able to run it properly. The CPU, the GPU, the RAM sticks, any storage you have on there, all of them require some amount of power to be able to operate. So something you need to make sure of is that whatever you're putting on your motherboard, you want to make sure that you have enough watts from your PSU to power all those components. Standard desktops don't really require all that much. Anywhere from 200 to 300 watts will do. If you start talking about really high-end gaming desktops, then that wattage number goes up fast. There's one last thing you really need to understand about power supplies, and that's efficiency drop-off. Let's say you have a 600 watt power supply, a beast. Just because it says 600 watts does not mean that you're actually getting 600 watts. At some point during that conversion process and through the constant flow of electrons, some amount of power is bound to be lost. However, there is a standard that all power supply manufacturers must meet, and that is the 80+ standard. That means if you want to manufacture a power supply that's going to have any chance of selling on the market, you need to make sure that it operates at least 80% efficiency. Let's take that 600 watt power supply again, for example. 10% of 600 is 60. Multiply that by 8 and you get 480 watts. So a 600 watt power supply operating at 80% efficiency is actually 480 watts. So you want to make sure that all the components on your motherboard don't require more than 480 watts, or else you're going to have issues. Now, there are a number of other rating levels that go up from 80%. There's the baseline, which is called the 80+. Then there's 80+ bronze, silver, gold, platinum, and titanium at the very top. And those efficiency numbers more or less increase at each level. But so does the price tag. And let's move on to talk about some of the basics of electricity. Electricity itself is the flow of electrons through a conductor, much like water moving through a pipe. Now, this isn't a perfect analogy, but it's a decent one to understand the basics. Now, the characteristics of electricity are measured in 4 different ways. That's voltage, current, resistance, and power. Voltage is the potential difference between 2 points. You could think of this like water pressure in a pipe. At your typical bathroom sink, you have water that's kept at a certain pressure up until the point where you have a valve or a handle that can open that and let the water through, right? Sometimes you have really high water pressure that's pushing that water through really fast, right? And sometimes it's really low pressure and you have a little bit of a trickle. But that idea of water pressure is how you can think of voltage, and voltage is measured in volts. Next is current. Now, current is the actual flow of those electrons from one point to another, more specifically between the negative and positive terminals of a power source. Once again, just like running water through pipes, the water needs to start somewhere and it needs to end somewhere. If you have a break in the pipe in between those 2 points, the water gets out and dissipates. Doesn't do what it's supposed to. Now, one of the main things that can affect current is the amount of metal that electricity has to flow through. Typically, a smaller wire equals smaller current, and a larger wire equals larger current. Just like smaller pipe, less water. Big pipe, more water. And current is measured in what we call amps. Now, this is where I want to take a trip back to the AC and DC thing. Remember alternating current and DC current? Direct current flows one way. In other words, it has a start and it reaches an end, and that's it. Now, this is where the water analogy starts to break down a little bit. Alternating current actually allows flow both ways, which is a little tricky to wrap your head around, so we're not going to go too much into it, but if you want to look it up, it's pretty fascinating. Next up is what we call the resistance. Now, the resistance is really just the opposing force of current moving through a conductor. And it's actually caused by characteristics of the conductor. You can think of this like a drainage pipe that's all gunked up and has old food in it and stuff. If the pipe's the conductor, then anything in there that's not allowing electrons to flow through completely smoothly is the resistance. And that's measured in what we call ohms. And last but not least is power. Power is the rate at which electricity is drawn from the power supply by the device that's using it. Power is measured in watts. It's actually a very simple equation to get watts. Watts is simply voltage multiplied by the current. The pressure times the size of the pipe equals the force of the water coming out the other end. In other words, the voltage times the current equals the watts. At any rate, electricity is fascinating. There's tons to learn about it. Hopefully, if you get to that point in a physics class in the future, then you have some deeper appreciation for it. There's tons of projects and different resources out there where you can tinker with and learn more about electronics and electricity. Thanks for dropping in, and we'll see you next week in the Forge.